Right, grade 12s. Let's have a look at another. This came off an exam paper, off the matric final exam. And they said, solve for x, 2 cos x is equal to tan 2x. Now, firstly, we don't have double angle formulas for tan unless we make it sine over cos, which would be very complicated to do that, especially to try and expand it. But I think that's the only option. We've got a 2 here, so we can't even use the co-ratio formulas as well. So the only way that I can foresee that we can do, or foresee doing this, or find a way of doing it, is to basically do this, to make, that would give you at least 1 mark, sine over cos, which I think that's pretty cool. Okay, now we've got a huge problem here, and I think maybe what I could do is possibly maybe get the LCD, multiply both sides by cos 2x. So in other words, just cross multiply, bring that up there. And keep them as sine 2x's there. That might work. Bit of a problem there. What I could probably do, this cos 2x is awkward, but I've got an idea. What if we do this? There's many different options that you could use. I know the memo had many different variations, but let's have a look at this. This is the same as 2 sine x cos x. Okay, 2 sine x cos x there. Okay, now if I divide everybody by the 2, I would then be left with this. Okay, let's have a look here. And what I would then do is, if I bring everything across, let's have a look what happens here. Bring that across. Sine x cos x is equal to 0. Now there's a common cos x there, so let's take it out. And I think this is going to simplify matters a little bit here. Cos 2x minus sine x looks a lot healthier, but still quite a challenging question this. Okay, so what I would suggest we do is we've got cos x is equal to 0, or the cos of 2x will then be equal to sine x. Now this is wonderful. We can use, there's many different options that you could use for this one here, and I'm going to show you. But this one, let's just quickly whack this one. X is shift cos, so it's plus minus the shift cos of 0 plus the k360, where k is an element of z, and then it comes to, the cos of that would come to 90. Okay, plus minus 90 there. And then plus, if you do that in your calculator, shift cos 0, that's the one general solution. But now what about this guy? There are many options available to you. And I'm going to link up everything we've done so far. If you take this equation here, well, there's 2 possible ways of dealing with it. The one is to maybe use our double angle formulas. Now, because it's sine here, cos 2x would be the same as 1 minus 2 sine squared x, which could work quite well if we do that there. Okay, now if we simply bring everything to the left, we have a trigonometric trinomial. Look at that. So let's multiply throughout by the negative, and we have a trinomial, which of course we can proceed to factorize. So that's 2 sine x. The sine x, probably 1 and 1. Let's test that. So if we go negative 1 plus 1, that should work. Let's check it. 2 sine squared minus 1, and then 2 sine minus 1 works. Okay, so there we go. Now, this would give us sine 2 sine x is equal to 1. So sine of x is equal to a half, or the sine of x is negative 1. Great! We could then get our general solutions. So for this one would be x would be shift sine of that, which is 30 degrees, plus k360. There's your 1. Or the other one would be 180 minus shift sine, which comes to 150. Okay, as you've done before. This one would be here. X would be shift sine of negative 1, and we would then get negative 90 plus k360. There's your 1 solution. Or you can go x is 180 minus this negative 90, which is 270 plus k360. And there you've got yourself some general solutions there. Okay, so there's 4 there. Now what about another method? Surely there is another method of dealing with this trig equation. Well, okay, let's have a look at this. If we take again the equation cos 2x is equal to sine x Okay, there we go. We've got cos 2x is sin x. We can use the co-ratio things that we did as well. So look at this. So cos 2x would then be sin x is the same as cos 90 minus x. There we go. And if we apply the rule that I showed you, then 2x is equal to plus minus the of 90 minus x there. And then don't forget to add the k 360, where k is an element of z. Okay, now we can break this up into two parts. 2x now, but be very careful. That must be bracketed there. Okay, it's plus minus the whole thing in brackets. So we could say that's 90 minus x plus k 360, the 1. Bring that across. 3x is 90 plus k 360. Divide everyone by 3, and there we go. K 120, and that's your other general solution there. Okay, but now we also have this one. So 2x is equal to negative, now careful in brackets, that, plus k 360. And if we then multiply out, negative 90 plus x plus k 360, it's going to work out pretty well. This is going to come, bring that across. 2x minus x is this, plus k 360. So it looks like we're down to 2. I wonder how they compare with the others. We had 30, 150, probably because that's 120. You can see you can easily get the 150 out of that. They're different general solutions, but they actually would all give you the same. Specific values or angles if they asked for a specific solution. Okay, so that's very important. So remember the golden rules of trig equations, and remember the rules, and for cos especially, that there's many different ways. For example, they might say to you, for example, they'll give you an equation like this: cos squared minus sine squared is equal to 1, and they say solve for x. Now, it would be kind of crazy to sort of, try and work with these things here and work with the squares, but you know that this is cos 2x, so rather convert to cos 2x. Then it's easy, because 2x is plus minus. If you go the shift cos of 90, then you get a shift cos of or shift cos of 1. That's pretty straightforward, because then that gives you plus or minus 0 plus k 360. And there we go. So you would have then 2x is equal to k 360, and x would be equal to k 180 there. Okay, where k is an element of z. So any of those would actually work, like that. Because remember too, also, if you look at it from a trig graph point of view, if you take the cos where the naught comes in as well, if you got the trig graph, it's if it's 1 there, it'll be at 0. Also at 360. So you've got this period of the cos graph that works. So be aware of those rules of the game.